All right, so I promised one more video where it's a little trickier to figure out which side is the correct, or which angle is the correct angle when you have the law of sines here. So let's go through this just a little quicker than the previous video. We got a triangle here. Let's say this side here is 13.5, this side is 10, and you have a 40-degree angle in between them. If I want to find the missing angles and the missing side, I'm going to start with law of cosines. So 13.5 squared plus 10 squared minus 2 times 13.5 times 10 times cosine of 40 equals c squared. So then I have 13.5. I'm just going to type all that in because there's no unknown pieces on the left side of the equation. And that all comes out to be 75.418 as my c squared. And I take the square root of that answer, and I get a c value of 8.68. So let's put that in there. So now, just like in the last video, I'm going to try to find the missing angle two different ways. So let's say this is B and this is A. It doesn't matter which one is which. I could do sine of B over 10 equals sine of 40 over 8.68. If I do that, I can do sine of 40 divided by 8.68, and I get sine of b over 10 equals 0.074. Multiply that by 10 and take the inverse sine of that. So I get b is 47.78. And then subtracting from 180, so just 180 minus 47.78 minus the 40 degrees that was given at the beginning tells me that angle A should be 92.22. Now let's play the same game to find angle A. Sine of A over 13.5 equals sine of 40 over 8.68. Same game we just played, sine of 40 over 8.68. Then I'm going to multiply that by 13.5. So I have sine of A equals 0.9997. Do the inverse sine of that. And I get A equals 88.66. And B, I'll get by doing the subtracting from 180, is 51.34. So now here's the tricky thing. The biggest side is opposite of A. And in both of my methods, angle A is the biggest angle. B is the medium length side, and in both of those, B is the medium sized angle. And C is the smallest side, and C is the smallest angle. So that big, medium, small matching up idea, which is the easiest, doesn't work in this situation because we still have the same big, medium, small matching. So the method my student used, which I think is very nice, is to pretend we have a right-angled triangle. We can use any of our side lengths to pretend is the base of the triangle. But let's look at angle A, pretending that angle A is the 90-degree angle, because angle A is the one that is closest to 90 degrees. So I'm going to be able to figure out, is angle A obtuse or is angle A acute? So let's redraw the triangle there. I'm going to pretend, so this is angle A. So this length right here, you can use this one as 10, or if you wanted to, you could use this as 8.68. It doesn't matter which one you use right there. I'm going to use the 10 because I had a given angle from the beginning of the problem of 40 degrees right there. So 40 degrees is adjacent to 10, and here is the hypotenuse. So I can say cosine of 40 equals 10 over the hypotenuse. In other words, the hypotenuse is 10 divided by cosine of 40. So let's do that. 10 divided by cosine of 40, and we get 13.05. Well, what did we just figure out here? We figured out that if angle A is a right angle, then the hypotenuse is 13.05. But on our real triangle, this was longer than 13.05. So what we can write is 13.05 is less than 13.5, and that implies that angle A has to be bigger than 90 degrees. So it has to be obtuse. The other way I could do it is use the law of cosines and inverse cosine to see which angle works out. But I just wanted to show this method from my student again because I think it's really clever and a nice way to do it without having to go through the law of cosines again and again and again. It also does technically use cosine to get it done, and cosine will always work because cosine gives you different answers for acute angles compared to obtuse angles, whereas sine gives you the same answer for an acute angle and its obtuse buddy that match up to 180 degrees. All right, so comment, ask questions if there's anything else I can explain. Thanks for watching.